Hi, welcome to my YouTube channel. I hope you're having a great day. This is next level technicals. So, in continuation of my previous video on MPLS based layer 3 VPN that I use Cisco to carry out the demonstration, and in this case, Cisco devices. In this case, I'm using Mikrotik router for the same MPLS based layer 3 VPN. So, basically, what I do in my YouTube channel I I carry out routing and switching configuration using network simulators such as GNS3 or Packet Tracer. So, however, when I carry out a configuration using Cisco, I also try to do the same using my boutique. So, for this particular video session, it's going to be a little bit lengthy, but I urge you to be patient with me and then tag along. However, if I just want to let you know that this particular topic is actually a little bit advanced. It's a topic you find in CCNP in the case of Cisco and MTCROA in the case of Mikrotik. So, and without any further delay, let's dive right into it. So, before I continue, there are some certain introduction I will make, but I will not go into details on those theories. If you want to know more about those theories, check my common video section. I did a little intro into them. So here is a little bit of intro. The prerequisites for you to carry out this particular configuration is that you need to have basic knowledge in IGROP, Interior Gateway Routing Protocol, or Interior Gateway Protocols, such as EIGROP, OSPF, and ISIS. EIGROP being renowned uh, Interior Gateway Routing Protocol, open shortest path first for OSPF, intermediate system to intermediate system. Then you need the knowledge also about BGP and how it works. You need knowledge in MPLS and VRF, virtual routing and forwarding. I'll be leaving this brief note in a link below. However, I would just want to do a little bit of intro into these different protocols. So for MPLS, which is a multi-label uh, multi-label protocol switching, multi-protocol label switching. Sorry, my bad. Multi-protocol label switching. So MPLS layer 3 VPN represents an alternative to IPsec VPN, and when supporting a complex topology, these are typically used in a service provider environment. That is this MPLS protocol. So, I don't really want to go into the theories in details because I want us to do more of lab. So, some of the benefits of this MPLS layer 3 VPN is that in the service provider environment, basically, they provide some level of privacy or security to the customers, and it allows for scalability in a service provider environment. For example, you can add and remove devices or do some design in your network without actually impacting on your services. And then it provides the privilege for service provider to provide one or more customer who are using the same private IP. I'm talking about MPLS based layer 3 VPN. So, what that actually means is that if you as a service provider is using the same subnet of IP as your customer, normally that will cause issue in your network. So what do you do? MPLS based layer 3 VPN is an alternative with the help of VROF, virtual routing forwarding. This virtual routing forwarding actually breaks, it looks like uh, uh, the customer. It looks like they are the only one connected to the router. However, this virtual routing forwarding is just a means of creating other routing tables within the same physical device. So, why do we need IGROP? So, IGROP is used. It is one of the internal gateway, internal or interior. These are just some English terms, but interior is actually more appropriate. So, interior is what I'll be using in this topic. So, interior gateway routing protocol are actually needed to enable IBGP loopback reachability because we'll be using loopback. So loopback reachability is one of them. And then another thing is to enable or help propagate LDP, label distribution protocol. That's the protocol that aids the distribution of MPLS labels. So so brief intro into MPLS. MPLS is sometimes called Layer 2.5 protocol on the OSI node because it can carry anything over MPLS paths. So actually, it like the term is, it appears in MPLS Layer 3 OSI, you appear in layer 3, it also appears operate in layer 2 also because you have PPLS, which is a purely layer 2, it operates at layer 2, and then we have the layer MPL, layer 3 MPLS, layer 3 VPN, which operates at layer 3. So even the EDA, the EDA of that MPLS, it has layer 3 and layer 2 EDAs. So and what do we need? Then what is a multi-protocol? This BGP. Why do we need BGP? Now, uh, BGP is actually a protocol that powers the internet. It propagates its network using one of the attributes called ASN, autonomous system number. But however, in this particular topic, we are using an extension of BGP called VPN V4. So you can also, but when you now use it for VPN V4, it has now become multi-protocol BGP. You understand? Or you call it MPIBGP. In the sense, multi-protocol interior gateway protocols. So you use this particular protocol is used within your what do you call it, within your domain, your administrative domain. So that's that for BGP. Uh, then for the VRF, as I earlier explained, virtual routing forwarding, this allow a router to run more than one routing table in a single device simultaneously. So I will not go too much into the theory because the purpose of this lecture is for demonstration of MPLS based layer 3 VPN. Each of these topics are large. They are topics of its own in literature. IGROP, such as IGROP, OSPF, ISSS, BGP, MPLS, they are topics of their own. So without any further ado, let us go to the lab and see what we are doing here. So for this lab, in my CISCO diagram, I actually did two hubs, two branches, and two branches, each hub for each company, each hub for each company. But I noticed that video took almost 3 hours. So I decided to say, okay, let me reduce this configuration to just a hub, which is a customer, happen to be the same, managed by the same administrator with the same interest, just a single company. And it can be a CAT company, it can be UAC, it can be BAC, whatever company it is. Just one company. I don't want to do too much about it. So whatever concept that is applied here can be applied if you are adding more routers to the network. So what I'll be doing in this router, what most ISP do is that they give a static IP. When they do an MPLS based layer 3 VPN, MPLS layer 3 VPN, what they do is they'll just give the customer a static IP. So the customer now know how he will route his IP between uh, between its other branches. So, but in this particular diagram, what I'll be doing is that for the hub, I'll be using BGP. I'll be because MPLS there are three VPN is actually a protocol where it's actually a means with which the ISP partake in routing process with the customer. But it actually also help the customer in the sense that if the customer does not want to do too much routing in the system, the ISP can assist. But with this kind of service, it is actually a premium service and the customer will have to pay well for it. So that is just the difference between just giving the customer just an IP or running a routing protocol with the customer. So for this hub, I'll be using BGP to do routing protocol with the hub, while for these other branches, I'm using OSPF. I'll be using OSPF for short test part first. So while for my previous lecture, CISCO actually have other alternative routing protocol. Routing protocol. So I use BGP in one section, use OSPF, and I use EHRP for another router. So here I have only two options. BGP. I actually have a static option to do here. I just want to use how you can use routing protocol to run a different route, and your route will not appear in any of these routes. Only your route will be seen. So let's log into the P router because this is the provider router, which is P router, and I can call it the hub or ISP. Then I'm just giving it the P. P actually supposed to be not supposed to be an edge router at all. It's supposed to be in between. What do we call it? Supposed to be like a core where all other PE routers are connected to, but no other CE customer edge router are connected. Like these ones are called CE router, customer edge router. So that is actually what P is. So permit me, I'm using this as P. So it's just for me to for you to see how it works. I'm supposed to give it PE, but I need a 10 like P. It's supposed to be just like I earlier explained. It's supposed to be where other PE routers are connected to, but no CE router is connected to, more like a core router. That's what it is. So then this is a route reflector router, named arrow router. So for this particular diagram, so let me not just waste time. Let me just go into the configuration in details. So I'll log into the P router. First and foremost, let me show you this. The ISPN, this domain, I'll be using 65,000 as ASN, autonomous system number. I'll be using loopback 10.10.10.s for these routers. And the customer, which is this customer edge equipment. Customer edge equipment, it is we call customer edge equipment when that particular router is sitting at the ISP end but providing services to the customer. It's customer edge equipment. But when that CE router is now in the customer premises, it is now called CPE, customer premises equipment. So, however, these are just MPLS terms. Excuse me. So, however, if you check this IP, I said client IP 1610.x or s, ISP IP 1610.x. Now, if that is the customer using the same IP as the ISP, this is not possible without VROF. If you do this, there will be a conflict in your network and there will be issues. But with VROF, virtual routing forwarding, each router will be working, will be having several two routing domain instance, and that will allow you to now have the same IP on the same router. In Cisco, immediately you assign the same subnet, it will show you to bounce back to you and tell you you are assigning the same subnet on the interface. But with VROF, it is possible. So I'll log into to P router. Let me form a neighborship with the internet. This is the cloud internet. So let me log into the P router and see what I have there. I've already configured an IP address and I can reach the cloud. BGP is what power the internet. So I will go to routing, I'll go to BGP. I'll create a template. There's a template there already by default. I'm using, okay, I have to assign a loopback. In router OS version 7, they have done, normally you are supposed to come to a bridge and then add a bridge and create a loopback. But in router OS um, version 7, and a logical interface has already been created for you to work with. It's actually a nice thing to always assign a loopback to the router. So I've assigned this. So I'll come right now to this router ID and I'll include this, and then 65,000 ISP, what do we call it? ISP autonomous system number. If you do not assign, it is actually optional, but it's a nice thing to do. If you do not assign 10.10 loopback IP, by default the router will choose IP with the highest prefix, like 10.10.10. It's a slash 32, and the prefix is slash 32. So definitely I've assigned it to it. But assuming this was not assigned, there's another. Let's say this is the only one that is there, and there's another prefix that is slash 32. That 32 will be taken as the router ID. So it's just a nice thing to do, but it's optional, but very very nice and important. But in VPN v4, it is a must because you need a loopback to work with. So if I don't choose an address family, IP will be taken by default. So in this case, I'm choosing IP and I'm choosing VPN v4 because that is what I need it for. If I need the BGP signaling, I will choose this. So if I can do IPv6 routing with it as well. So that's that. And then I will establish a connection with the ISP, which is the upstream. The upstream provider, which is this guy here, is the IP address is 172.16.10.1 and the remote areas is 64999. Now, these remote areas in your lab, these are topics I will discuss when I'm coming to BGP. In your lab, you should ensure that you use the private range of IPs so that you don't have issues with your lab. So then it is actually eBGP. I'll take connect, I'll take listing, and then I will apply. I'm supposed to have a session. Okay, so I have a session, and then let me check if any route is coming from that BGP, and I have a route coming from the BGP. So let us quickly go for P1, P2, and route prefix and do that. So I will use GROE in this scenario. So I will assign IP address on those tunnels, which is the underlay network, and that is the tunnel IP. What I'm actually doing here is called VLSM, variable length subnet. So I just pick one. I'm not using the default IP like 172.10.1, 172.17.20.1, or 170.10.1, 170.11.10.1, 117.17.12.1. Those are default IP. Before you know, you can run out of IP easily. So I'm using VLSM, variable length subnet, and OSPF support VLSM, and also classless interdomain routing. So, however, VLSM and NAT, network address translation, are those two tools implemented that enable us up to today. We have not run out of our public IP addresses. So those are the two things that is helping us that we have not really finished with our IPv4 public addresses. So that's the VLSM I'm doing here. In case you are wondering what I'm doing, if you check, there are different subnets, but the same supernet IP 172.16.10. The supernet can be /24. So let me go to the one. So the tunnel is up. I actually labeled this strongly. I don't have PE3. I have route reflector router. So my generator is running. Let me assign an IP address to it. Let me confirm the end, the up router to see if it is reachable. So I can use .5. So the route reflector router, I need a generator for it as well. Java is supposed to be home. Okay, I was using I went and used the underlay IP address instead of the IP itself. Instead of I went to use the overlay IP instead of the tunnel the underlay IP service provider IP. So the tunnel is up. Send an IP address on that tunnel. It's running. Let me confirm this from the P router. Okay, I'm good. Let me confirm reachability. Okay, so I'm good. And the next is for me to stabilize that tunnel. I'll do the same here. say for P router, for PE1 router, I need PE1 router. Where are you? Alright, here it is. So I believe this is stable. I can actually, it would be nice as well for me to define that here too, but I don't really need to. It was very necessary as well, but just to buy time. So another thing that I will now do is to advertise my loopback IP address. Let me come to this routing OSPF router ID. This is a nice, that's how you need to do. You need to configure a route ID, otherwise it will choose the highest prefix in the router, but it's a nice thing to do. So I'll apply this and then I'll come to routing OSPF. The router OS version 6. Instance and areas are there by default, but here you define them. So my router ID is the one I defined earlier. So I'm going to add, this is the area, OSPF area 1. I'll add those GROE tunnel, that is where I'm interested in. OSPF interface network command actually is used to for the interface that OSPF interface to participate in OSPF process, not advertise prefix. No, but for the interface that are concerned for OSPF to participate in OSPF process, so that those hello messages can be sent out of those interface. And the GRE and kind of IP I'm assigning, this type of IP is /30, more like a point-to-point IP because it's only two usable IP /30 IP. GRE also somehow works as a point-to-point kind of protocol. So protocol picking is point-to-point, and then I will apply and make every other thing I'm good to go. So let me say P1 routing router ID. You can see it went and picked 172.17.10.2. It is why we normally define, otherwise you have to be clearing your SPS process. You have to define a loopback for it. It is a nice thing to do. IP address, I hope it's there. Okay, alright. So routing OSPF instance, what ID that I'm working with, and then the area. There is templates, the GRE that I created, and then what else? Point to point. In the moment, 172.17.10.0/30. I should be having neighborship coming up anywhere from now. IP address. So, yes, I have neighborship coming up. I need to see full state. So now, this is a misnomer. This is an issue I used to see with many ISP. But I'll come to that anyway. I will explain ISP or network engineer. I will explain that later. Just a small error anyway. Then I'll come to this place. My loopback IP is 10.10.1 here. and I'll take passive. Passive means that it will not send OSPF updates, but it will receive OSPF updates. So this network statement is not actually advertising this preface. No, it is because the connected IP. If you come to IP, if you come to route, these are connected. Excuse me. These are connected interface, and connected interface. Uh, Immediately you enable them here, they will start sending LSA, link state advertisements. Not that your network segment is actually advertising the network preface. No, because the active interface is active and there's an IP address there, so it will send an LSA out. So I'll do this, and then let me do the same thing from the back zero here. Sorry, I'm having a little bit of cough. Let me switch this anyway. If I must deliver on this video. So now, this is what I want to really correct. Some network engineers always tend to come to instance, will now do redistribution of connected routes. It is actually not the best practice. You can do it, but this is not the best practice. Connected interface are your preface, your preface that you intend or you wish uh, to advertise. You wish that it should be reachable in your network. They are your preface. By the time you do redistribution of connected interface, now what is redistribution? What do you use it for? You redistribute. Redistribution is used when you are redistributing protocol of different protocols. For example, you are distribution from BGP to OSPF, though it is not recommended because BGP is a very large protocol, they support very large protocol. Or you are distributing protocol um, um, from EIGRP to OSPF, or OSPF to EIGRP. Those are what you need distribution for. Also, static route. Static route, though it is assigned by the administrator, but immediately you click redistribute, which is this static route, it will be seen as an external route because it is not generated by the OSPF itself. Now, all these routing protocols have what we call administrative distance. Static route by default has administrative distance of 1. OSPF have administrative distance of 110. Now, if you redistribute static route, though it is an external route, but it will be preferred as the best part. Why? Because um, it is a distance of 1. The same goes to if you have two different protocols running your router. For example, you have EIGRP, you have OSPF. EIGRP has administrative distance, internal route as 90, external route as 170. Those internal routes will take precedence over OSPF. OSPF will take precedence over RIP. RIP is 120 administrative distance. Now, OSPF, the designers of OSPF only distinguish between in EIGRP, for example, you have I'm taking time to explain this, why it is necessary not to do redistribution of connected route. It is only needed when you are doing distribution of certain protocol. And that the reason you do redistribution of protocol is maybe the router you are using, another router you are using is a legacy router, an old router, and you are using a new modern router, and possibly that particular router only supports OSPF. So you do distribution. Another major reason of distribution is when you are merging companies. Company A is merging to company B. You do distribution. Those are the reasons you redistribute, not your internally generated route. Now, let me give you a scenario of EIGRP. EIGRP, when you do distribution of EIGRP, and in that router you have RIP also running. You understand? You have RIP version 2. also running in that router. You have PHP running in that router. And you do the distribution of connected routes. Connected route will be taken as 170. The administrative distance will be 170, while the RIP is 120. You can now see that the RIP will take precedence over ERGRP, which is a very bad scenario because ERGRP is a very nice protocol, and that is your own route. But OSPF will not do administrative distance for different distribution. The only way it differentiates between uh, uh, internally generated route and external generated route is using what we call external and internal route. You will see external route as external type 1 or external type 2. I will explain this OSPF in one of my upcoming videos. Now you see external type 1, external type 2. It does not have difference in adhesive distance. It's just one thing. But when you are running it in your domain for best path calculation, you are not supposed to use redistribution of connected route. I will demonstrate that in a moment. Now, let me remove this. I've advertised loopback here as what do we call it? I would have done that, but because of the tunnel, I have to be specifying what do we call it? What do I have to be doing outfitters, as in I'll come to this place, routing, fitters, rule, add chain. Then I'll now write OSPF out, the rule. And I'll say okay, add OSPF out, rule, if. So I'll not be doing all this. While I'm doing this, I'll be excluding the uh, the underlay network when I do distribution of connected route. When I do that, because if I do distribution of connected route without excluding that public IP, what will happen? This is private IP anyway. I'm using public IP terms because it is the underlay network in this context. However, when I do distribution of connected, it will redistribute that public IP. It will now being that the tunnel looks as if it's the shortest path to the distance, it will want to redistribute that public IP and the tunnel through the tunnel, and that will cause recursive routing. And what you will see is a flapping OSPF or whatever protocol you are running. So you have to exclude it here. That is one of the essence. Now, I've explained retrieving of connected route. Let me come to this route. I should be having the loopback IP since I've advertised the connected interface here 10.10.10.1. If I come to IP, I come to route. You should be seeing that 10.10.1, which is dynamic OSPF. Look at it. If you come to OSPF, what you are seeing is OSPF type intra area. Intra area is LSA type 1. Then we also have LSA type 2. LSA type 2 occurs when you are in a broadcast, the interface are connected to the interface to the OSPF process. They are in a broadcast domain, maybe like in a switch network, or you are using an IP like /28 that has more IP, 28 and above. So that is it, where you have DRO, BDRO, backup destination router, or other support. That is when you have LSA type 2. Then we have LSA type 3 called inter-area. Inter-area being that if you come to routing area, currently I'm running only one area for this particular domain, only one area. So it is inter-area that I'll be seeing. But assuming I'm having multi-area, this one is in one area, this one area. So what I'll be having in that route that I saw earlier will be inter-area. I will explain all this later in OSPF. These are for best path calculation. But network engineers, when they come, they just don't want to take the stress if they have so many IP assigned here. They don't just want to take the stress of doing the right thing. You just do the distribution of connected route, your own route. And by the time you do distribution of your connected route, when you now come to this particular IP, it's because I did advertise this. That's why I'm seeing this here. You'll be seeing it at external route. What is external? The external route, like I earlier explained, is coming from another protocol. is coming from another company. It's coming from another device that is not maybe another OSPF process that is not actually part of your administrative domain. So those are what do we call it? External. You will see external type depending on the type you set because you can specify type as well using filter. So actually took time to explain this. The best thing to do is you come to the interface. Now, if you have an IP address assigned to, let me say, to LAN, let me say filter 5, let me say 172.18.10.1 slash 30. Let me do another for filter 7. Assuming these are what we call LAN IPs, your local area network IPs. So, assuming those IPs are your local area network IP, what is expected to do is to come to routing OSPF. In OSPF literature, OSPF theories, whatever you read about OSPF literature, the literature is that you should come to the interface. You are not advertising the network. You can advertise the network anyway. You come to interface. You come to yes, all interface. Leave it on broadcast. Then you tick passive. Now in Router OS version 6, when you do this, those connected interface will not be advertised. You have to now come to the network in Router OS version 6. You have to come to the network and be specifying each of those interface on those what do you call it, that are connected on the LAN side, but ensure they are passive. You have to now specify them. But OS7 designers or developers, I understand that they come to do the right thing in OS version 7. When you just come to this OS version 7, what I observe is that mainly you come and you tick off and you tick passive. It will automatically advertise all the LAN network on that router. That is what I observed in OS version 7. I think they are following what the OSPF process is supposed to do in OS version 7 and then put those to them. But in OS version 6, that does not happen. You have to specify the network address. It is not that the network address is advertising the IP. No, it is actually telling the router that this particular interface should should send LSA update, but not receive. Should receive LSA update, but not. What am I even saying? Should send LSA update, but it will not. It will not send LSA update, but will receive LSA update. That is actually what it's saying. So those connected interface will now send the IP that are there will not be appearing in every other route. So that is what I'm trying to actually explain. So like just like this particular 10.10.1, and I'm seeing it as intra area, which is a network just like inter area, just in one particular area. So I actually took time to explain this. So and the same thing with the connected okay, that's BGP. Let me see the other guys. You see they are having inter area, not external side. So let me now ask the other routers. And even CISCO devices, I don't think CISCO devices for me because if you do passive interface default CISCO devices, those interfaces will not be advertised. So you have to add the network address there. So routing, so to put back here. It is actually the best practice what I just talked about. It's not like you cannot do registry of connected routes, but it's the best practice. Routing experience. So I have full states, and I'm supposed to be having all the loop back running now in this router. So I have all the loop back running, and I have all the loop back populated in the router. So that is the essence of one of the reasons of the IGP. So and what I want to further describe in this router is that I will now create a route reflector router. This particular route is going to be called route reflector router, and these are going to be called ROC, route reflector clients. Route reflector clients. These are going to be clients of this route reflector router. To them, they think they are forming a full mesh to this router, but not knowing they are clients to this router. So, however, um, for this particular diagram, it is extremely not important to configure MPLS on this particular router. MPLS is a must here because it is an edge router, a provider edge router. MPLS is a must here as a provider edge router. The same here because at the edge router, those are where the MPLS are imposed and then and also removed before going to the router. Coming back to the router, they are imposed and it goes to the MPLS core network. And if assuming this particular router is in the transit router, uh, label switch routers, assuming it's in its transit router, as in it's in between the PE router, it is called, let's say, LSRO routers. In such a case, I have to configure MPLS, but it is not in the transit, it is outside of the transit. So it is not a must for me to configure MPLS for this router. I will do that here and everything will work as expected. I'm not doing MPLS, as you can see. No interface, no instance. But I'll do for, let me just do it now. MPLS, MPLS instance, loopback IP is 10.10.1. Excuse me, 10.10.1. It's not a must, but just let me just pick it. Address family, any other thing that need to be done here. Okay. So the interface that participates in that MPLS process is PE1 interface, accepts dynamic route, loopback one. These are extremely not important. Why I'm saying this is excepting you are connecting to another administrative device managed by another administrator that happens to have fine-tuned those MPLS timers, then you have to do the same according to its own. However, if you don't configure it, default timers will take place. So I will do the same for this guy. Remember, I said I'm not doing anything for our graph reflector router. So this label, I'll do the same. These are good, right? So MPLS, PE. This guy is .2. Just confirm that's .2. .2. And then IP will be keeping by default. I think that's that here. Let me take this video channel asset. .1, .2, sorry. Let me see the PLS video account. Okay, that has been found. Let me see the new worksheet everything about dynamic operation. Okay, that's that for that. Let me go to, I think those are the two routers I need to do this with. Yeah, these are the two routers. So let me quickly configure VPN V4 routes for those other router as a route reflector client. VPN V4 to P router. and then remote TS is 10.10.10.1. Remote address, like you say, 65,000. The role is IPGP connect and listing. The TCP updates with port number 179 should be sent and should be received. And local address is 10.10.10.4. Let me see what that is. Yes, that's it. So for the P router, let me apply and I'll copy, ensure this is enabled, otherwise your VPN V4 will not work as expected. Then I'll do to remote address 2 VPN V4 to PE1. Address is 2. Redaction is 5. Then I'll do for PE2 VPN VPN V4 to PE2 webpage. And the 2 big back IP is what is 3. It's 3. I think everything is fine here. In router OS version 6, you need to go options, update source, and update from loopback IPs. I don't know why they remove it in OS version. In OS version 7. So let me quickly do the same for PE router and routing BGP. And I forgot to do something. I have to specify that these other routers are their rack reflector clients. So let me do the same routing BGP. BGP2, let me just so that to type VPN for to our router. Go back to step 4, 65,000 IP, just like BGP. And the local is .1. Comment and send. I'm supposed to have all the problem, not choose a template. I'm supposed to have a session coming up. Okay, 2 sessions established. And let me quickly go to this other guy here. Routing BGP VPN for our router. The net address is that 65,000. Local address here is the 2 address, that is the right address. The 2. And then things like that. Okay. Should be having a session here too. If you have a session, so you can establish for PE2 to routing BGP. VPN4 to router. Choose the template. Go back that 65,000. Local address here is the 3. Units and listing. Apply. I should be having a session here too. So that's good. That's that for that. So now we will now go to the VRF process. So I'll come to that's just what I need to do at rack reflector router. It has finished with its job. What does this rack reflector router does? It reflects the routes coming from here. It likes, because normally BGP works as AS. It works with ASM. It's one of the attributes. To propagate its network briefings from one part to the other. and to get its best part. However, when we use it in an extension like IBGP process, so scalability becomes optimization becomes an issue. So there are two options uh, for optimizing BGP or scalability to solve scalability issue in BGP process. You have configuration, BGP configuration. I'll talk about that in one of the BGP session. And you have BGP route reflector. I'll also talk about that in one of the upcoming session. So, however, what does this route reflector does is that it reflects the route from here that comes to it to this other route. The route reflector rules. It reflects the route that comes to it to this other route. All that is just to prevent loop in the BGP process. Otherwise, if I don't do this particular setup, I have to form a full mesh. Full mesh is that I'll do a BGP session with this, BGP session with this, BGP session with this, BGP session with this, and that would be messy and very unmanageable when it comes to a very large network. So route reflector is a very simple way of optimizing your network using multi-protocol BGP. So I will discuss that in one of the upcoming sessions. So the next now is for me to what else? I have to define the VRO. On this interface, the customer are connected to ETA1, 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 and okay, nothing here. ETA1, ETA1, ETA1. And look at this network prefix. I said the client and the ISP are using the same prefix. Remember the underlying network, this service provider, what he used to give network to this up downstream network is with the same network prefix, and the same clients are using the same private IP. So if I'm to assign it to the physical interface, that's going to be an issue. But if I'm to use the same IP, I have to create VRF. However, VRF is also very important in MPLS because of the route target import and export. So let me define the VRF now. I'll come to IP. So I assign IP address. Let me go to ETA2. You will watch. I'm going to, since I'm using the same network before, you see what it will do. I'm assigning the same IP here, and what I'm advising it, but the same network on ETA1. I'm assigning .1 because I want .1 to be at the ISP end. It will shut down the BGP immediately. It will shut down. You see the GRE has been shut down. It has affected the network. Everything is no longer reachable. So I will now create, because if you come to IP, you come to route, they are directly connected route. You cannot have the same prefix showing up in the same routing table. Where is that one that created? Look at it here. The ISP prefix as well. Look at it here. They are showing cost bus sign, which means ECM, equal cost multi-part or so, ECMP. That is even Mikrotik. In CISCO, it will bounce you off and tell you are using the same subnet. It will not even allow you to assign it. But this has actually shut down the network. To solve this, you have to create a VRO so that this routing table will be. It's not like we are breaking it physically, but virtually we are creating a virtual table, because all the table now is main table. So we have to create a virtual table for this IP to exist on its own. I'll come to VROF. I'll leave it that way. I don't really want to. Um, but I'll give it a name anyway. I'll give it a name just to make things nicer. That it's a 1 hour silent, because VROF means a minimum of one interface to function. So some service provider used to use this VRF name is what we call route distinguisher. You understand? You can actually, or any other name you can give it to. But let me just leave it at VRF, right? Just VRF1. Immediately I will assign this to VRF. This GRE tunnel should be off. Let me go to IP address. One. As you here, you see we are now back up. So because if I come to IP and I come to routes, this is main. have another table now that's been created for this. So that's that for that. So I'll come to routing. Let me do the same thing for this other router. IP PROF data one. I'm going to assign. It is actually not a nice thing to do to have the same subnet. Just plan your network well. But I'm just giving you a scenario when it comes to such instance. Data one, or if the customer requests for such a service, they should pay dearly for it. They should pay a premium service for it, because this is hardware resources that are being used and a lot of knowledge also going into this particular service. So Twitter one, if you want to make this dot five, to make it dot five on Twitter one, so I'll come to this other guy too, YouTube IPVROF Twitter one, to IP address, this same IP port dot 9 on Twitter one, and 72.16.10.9/30, and Twitter one. So the next is for me now to define route, come to routing, come to BGP, VPN v4. You define the route distribution. The route distribution is you can use low back IP and number identifier. Just any number you know that is unique to this local router. This is only locally important. Locally important, 65,000, not in the core. So just to distinguish it, I'll use the low back. For this particular customer, I'll use one. So I'm using per VRF. The VRF is VRF1. And then let me come to this P1 because I want to do the same there at the same time. I'll say 65,000. The look back here is 2. And what did I do here? Okay, yes. And, so 2 and then 1 on the VRF1. I'm using what we call it a VRF. So here I'll be exporting this route target. This route target number, which is autonomous, which is popularly used, constant number, and the number identifier for the customer or the client should be unique in the MPLS core. Now, route distribution should be unique in the local core. It is only significant in the local core. If you have the same route distribution in the same local router, you will have issue. But if you have the same route distribution in the same network, not the same router, you don't have issue. But what should be unique in your network is this route target import and route target export. That should be unique in your MPLS core network, not only your router, because it is with that those routes are being identified. Routes that are in this VRF or connected interface. So I will export this guy out. So I will export this guy out. Let me go to this and do the same for the other guy. So the look back here is 65,000 3.1 VRF. The VRF, I'm exporting this guy out. So so the P, which is the core router, is where I'll be pointing to. Now, why the provider router? Because it is believed that at the provider router, which is the hub, this particular hub is where the server is, that these branches are going to be accessed. So everything points to that direction. So I'm going to import P1 and P2 here. I'm importing this guy here. I'm also going to import this guy here. That's all that needs to be done here. So, and this particular guy, I will import it in those other edge router. So that's that just needs to be done. So and now, if I should go to IP routes, I should be having okay, I've not gotten to that yet. Okay, all right, let me check. Not yet. So then, so the next is for me to go to I think I need to go to the customer end. Okay, the next I need to do very important. That's what I'm not seeing the route here. And I a little bit escape. I have to do redistribution of connected routes. Now, I actually preached earlier on. I spoke about distributing connected routes, but in this case, you can do it. Why? Because you are redistributing from protocol to another protocol. Though all we are trying to do here is to establish connectivity. So connected here, you can actually redistribute because even when it gets to the OSPF end, when you are distributing from OSPF to from BGP to OSPF, there's what we call SIG metric. The metric will change. So it is not what you distribute here you will see in that OSPF. So it is protocol to protocol. You can actually do it here just for reachability. So connected is very important to be distributed here, very important. And if you have a static route in that VROF, you do this. But I don't have static route, so I'm not doing that. I'll stop here. I will explain what I need to distribute here again later. Then this is actually very important, distribute connected. And then the other router, the default route, very important, connected route. Excuse me. So if I come to this route now, I should be having some IP address coming from. This did not come well with me. I'm not having what I need to have there. After I imported what needs to be imported there. Issues coming from this router. Okay, that's not the problem because that route is not something that I cherish to see. IP route, IP route. Let me see the routing flag. Dynamic routing BGP MPLS. This is just BGP doing its job. So I have to enable MPLS here, and then I thought I actually enable MPLS here now. 2.3. Then put it here. This LDP interface. I thought I actually did this thing here. Asset routes. And then this down here. So let me. Okay, see, it has changed now. So I should be having MPLS table coming up here. So dynamic active and BGP MPLS. It was hardware offload that was seen earlier on. So this is how it's supposed to appear. So let me come to IP routes and see if I'm having here too. The other routing table VRF1. Okay, good. So now let me go and form a like I earlier said, I'm doing BGP with the hub. So let me log in to the hub calculator. Sorry for that. I'm going to use a protocol called Romo to log in to the hub. Excuse me. Okay, I called it B hub. So I made a B hub. So eta1. So IP address on that eta1 172.16.10.2/30. Let me ping .1 172.16.10.1. Okay, it is reachable. So routing BGP 172.16.10.1 65,000 remote layers. It is external BGP and of this I can actually specify local. It's optional in CloudWeb version 6 template. So I will let me get this template fixed. I said ASN number for the customer is 6501 65001. I'm not setting router ID, so it will choose a router ID for itself. So now something I need to do here. I have to redistribute because I'm using this BGP as an internal protocol for this customer. So I have to redistribute connected. Assuming I have a static IP here, I'll redistribute static IP. So that's that I need to do here and apply. So if assuming I have a default IP, if installed, if there's default route in the router, and if it is not installed, but you want it to be advertised, you choose always. So that's that for that. I don't have static anyway, so just connected. And let me just assign a loopback IP for us to confirm reachability on each of the router. For this 10.200.200.200. Remember, it's a connected route. Come to IP route. That loopback I just assigned is a connected route. So the BGP that is distributed just now is a connected route. So I'm not setting it alive. So that's that for that. So let me go back to the hub and do a BGP session with it. And I can actually create another session for this. What I mean by another session, another BGP template for it, and I'll name it one for the customer. It's also a nice thing to do, but let me just use the existing BGP. Then RemoteX 172.16.10.2 router ID 65001. Optional BGP and what we call it, connect and send. If I apply this like this, it will not, labor sheet is not expected to form. Let me check. You see, because this BGP is assigned from a VRO from the main table. For you to come up, I have to come to extra. This is how to do routing protocols with customers that are ready to pay. The routing table is VRO. The VRF itself is specified. What else again? I think that is all. Um, and this for this particular customer, I'm supposed to BGP actually in router a Cisco router. When you do a configuration like this, you only need to redistribute connected because BGP, as I said, is a ear-to-ear protocol to work by ASN. Since I've done that reflector router, I'm not supposed to do any other distribution. But I noticed that in Mikrotik router, you have to do the distribution of BGP as well. Now, this one is important that I should include because what I'm doing is BGP MPLS. I will choose that. Now, the BGP itself, that's the protocol I'm using to this hub is BGP. The BGP itself, I have to redistribute it, but it is not actually ideal because in Cisco, for example, although that is my protocol, you just only distribute connected routes and whatever other things you want to advertise will be shared via the MPLS, via the VPN. So you do that here. You apply because this is the BGP connection with that customer. So I've done this, I've done this. What's happening here is I just connected and retrieve BGP protocol. This BGP protocol is the one I'm getting from here. Is what I'm distributing into this P router. This BGP MPLS is a route coming from every other route. This other route. Distribute this MPLS into this BGP process to the hub. That is what I'm doing here. And I'm supposed to be having a session now, and I'm not. And why is that? Is there anything I've done wrong here? Oh, did I touch anything? Pirata. I said, where's the BGP that was setting up? Oh, yeah. Let's check. The cost to the customer. Oh, like this is for the upstream. That's why it's good to get this thing properly. It is not this side is going to be anything see. And the local is that one. BGP is 6499 for the upstream customer. Right. So this is BGP for the customer. Customer. The routing table is the VRF itself, and the distribution connected, and which is distributing BGP, and then the MPLS. Let me come back here and see. The MTS is 65001. It's the BGP session, and the remote IP is I think 2. Yes, 2. Actually tempered the BGP process. Let me see the sessions. Only one, something I've already done. 65001 is up. Then this guy here. Okay, this is .1 to the upstream. That's .1. The local is 2. Let me restore all the connections. If this guy comes up, then this session comes. Okay, session has come up here. Okay, so we can before to take some time for the SPF and all that to come up. out. Wait, OSPF. I think OSPF should be up now. Okay, that's all. Let me see the session. The before has not come up here. The before. This is very funny. I was working on VPN before. This is just okay. I'm not supposed to specify. Sorry, VPN before is not this. Is the to the upstream. I'm supposed to do that for. My apologies. I was working on VPN before. That's not what this thing that I did here. This routing table is not supposed to be there. So for the VPN before, what I need to distribute is the connected, the BGP, let me see, this, just only the BGP, just only the BGP, and it is from the routing table. While for the customer, I need to distribute the connected. Let me see the VPN before. Connected. Connected is not okay. Connected BGP. Back to the customer. Let me see the sections. Okay, VPN before this at this point here, that's where I need to do. I don't need to do any distribution here. I don't need to do distribution here. No, not at all. Apologies on that. No distribution for VPN before. This area here is what I need to do something connected and BGP MPLS. Connected and BGP MPLS. So for the data connection to the customer, it has to be VRF, and then this is the VRF. The connected has to be distributed because I'm doing BGP with it. This has to be connected. Then the MPLS has to be MPLS with the hub has to be distributed to BGP session as well. Let me just put what I'm getting there. Okay, so I'm having the BGP route from those interfaces now from here. I think I'm done with this. Okay, nothing is to be distributed for the VPN v4 routes. Only this import targets are supposed to do something. And this BGP, I might come back later to redistribute it. In CISCO, you don't need to do all this BGP because BGP is works with amongst other attributes with ASN and with, in this case IBGP route reflector. So let me go to the OSPF process. You see that distribution process more easy in OSPF, but because of Mikrotik and how they do their own thing, so I have to be doing distribution between BGP, which is not really necessary. So let me go to the PE routers. PE1 for PE1, I'm doing OSPF. I'm doing OSPF, so I'll come to routing, I'll come to OSPF for this branch. So I have to create another instance. And the table is VRF. I'm using the same router ID that I've created earlier on. The routing table is also VRF. Then in this place, connected is important. I'll distribute connected, and then I'm redistributing BGP MPLS. See why I said OSPF is more easier because I'm not using BGP MPLS into OSPF. Connected is important on the interface. So that is just what I need to do here. Then I apply and then okay. The area I have to, let me check. Distance two. I have to give it a proper name to what? To customer. I'll create another area for it as well. I'll call this area dot one and I'll choose the instance that I created for that customer. I'll call it customer as well. So I'll come to templates, I'll pick beta 2. Okay, it's beta 1, sorry. It's beta 1. And I can leave it at broadcast, but let me just do point to point to come up by default. So I will apply, and then the instance area that I created is for the customer. So that is that. Apply and okay, then I'll move this up above uh, the back. Let me just reconfirm what I've done here. If you are already connected GPUs. That is that with that. Let me go to this branch router for more SPL process. Branch. I'm going to use one to access that router. Branch. Let me log in branch. So the IP address I assigned to that customer is 16 that IP address. So the customer does not to the customer router. The router does not know that it's connected via MPLS process, except you run a trace route. Then you see the labels that are formed along the path. Let me ping this guy if I can get. Okay, I'm reaching it. So routing OSPF, create an instance. Let me just I don't really have so much time. Okay, let me do what needs to be done. Let me just assign IP address and go back. 10.200.200.2. 10.200.200.2 area, and then the templates CETA1 point to point, and apply loop back 10.200.200, but it does not matter because I've done redistribution. So it is only the next hop is just the best part. The next is redistribution to another protocol, which happens to be BGP. So you can actually use redistribution connected in this scenario just to hasten your process. That's because your best part is the next hop, and when you come to the router, you come to VROF. Let me see. Let me see. I think adjacency even come up. It does not come up. Routing. Which interface is this guy connected to? ETA1, ETA1. Templates, ETA1, point to point. The VID was wrong. Let me check if I have adjacency coming up soon. Okay, so I have one coming up now. So I have OSPF. So, like I said, it is a inter area. You understand? But this is where it stops. The next is that I'm distributing this protocol. So what does it really matter? I'm usually now distributing it now from here. OSPF process now into what? BGP MPLS. You see, an MPLS back to the OSPF process. So it does not. And when it gets to BGP has its own method. So So I think that's that for this branch. Let me see if I'm having any routes because I think I'll still have some things to do. I only have the SPF here. Excuse me. So let me go to general router now. So let me just ensure things are working well for these two. Let me leave B. Okay, I'm supposed to be in B branch. Hub PE2, PE1, and the P router. Let me go back to get that B branch out. Excuse me. B branch. Routing to the this other route. PE1. Let me see the route I'm looking for the VRL route. So routing BGP, routing OSPF, the instance for that VRL. Let me see what are the distributed. BGP MPLS, BGP MPLS, and the connected interface. That's for this one I need. So let me go to P1, the P router, not P1, the P router. Let me see which version. It's actually the way BGP is being worked out here. That's what it's actually going to be prepared. So let me see. This is the VRF connected BGP and the MPLS. Okay. For the VPN before. Okay. Let me take BGP because BGP is what I'm using to do the processing. Let me go to that one router again and confirm something here. BGP MPLS connected, and then I need to distribute OSPF. Remember, OSPF is the protocol I am using for this router. So in the other router, for the P router, it was BGP that is distributed. But in this case, it is what they call it, OSPF, because we want to route in OSPF. OSPF is what I use to negotiate my route with that customer. Connected to the interface, and then the BGP MPLS. So for routing, for the PV, VPN 4 OSPF. This actually optional, but let me just go with it. So let me go to the PV router, to the router and see what I have. Okay, now every route is complete. I'm not having the loopback IP from the hub. And let me go to the hub. If I'm having this 200 disconnected route from the branch router at the hub. So good. Now I'm not having this 200 at the hub as well. So I've connected the hub and the branch router. So let me just exit this so to reduce the windows. Let me now work on the other OSPF, but that's just the process. Since we have completed it, let me hub is ready already. So let me just connect for P2 router. Let me put the P2 router. Close this one fresh. Once I think I'll be away for me. I've done all this already. So the IP address on that interface, it's our that's done already. So routing BGP, VPN V4, is connected, and I'm on OSPF. So I'll go to tick OSPF. It's optional, but let me just go with it. OSPF is what I'm running. For the hub, it was BGP. I was running, so I got BGP. So now it is OSPF here in the BGP process. So let me play go. I've seen OSPF into this BGP. So let me play go now and from OSPF process routing. Let me see if there's anything. Okay, I've done this already. Routing OSPF. I'll create another instance for the customer. See, customer, and then the router ID. I'm going to be working with the router ID I used before, and then the routing table is the VRF as well, and then the connected is very important. So this time around, I'm redistribution BGP. Remember, in routing BGP into VPN before, I redistributed OSPF into BGP. This was distribution. So in OSPF instance, I'm distributing BGP MPLS into OSPF. I did not take any of that one. So that's just the difference. And then that's for the VRF for the customer. The VRF is not new. We have had issue. This is VRF. So I'll come to what's in routing OSPF for now. So connected BGP MPLS all on VRF. I set the router ID area. I create area for it. Area dot one under the instance that created customer. I call this area customer, and then apply. And then the interface for that customer is ETA1, and the area is for the customer. I'm doing point to point. I'll apply, and then okay, I'll take this up. So let me go to the customer location and prepare for that customer. I'll log in with Roman because I'm logging with Roman. It's one of those cool protocols from Mikrotik to safely log into remote routers. C branch. I don't think I've assigned IP address on this router. So the IP address, let me quick check this P2 on ETA1 is .9. I'll come to this, I'll tick 10, and then it's on ETA1. Let me just confirm the reachability. Think of mine. Okay, good. So I'll come to routing OSPF instance area is .1. It's 1 templates. I'll pick ETA1 and point to points, and it's a point to point link. Let me see if I have the membership coming up here. I should be having a membership. I don't know why it's taking time. So I think it's ETA1 there. I need to redistribute the connected as well. Let me see the area that's formed. Okay, that's okay, full adjacency has come up. Let me see the routes that I'm having here. I won't have loop back here anyway. So I'm having the loop back IP from the hub. So let me add that's a success. IP address on the loop back. 10.200.200.3. That's what I'm just using to confirm these informations. So let me go to the hub now and confirm. Um, there's the hub of the router. I exited it, I've exited it. Let me go to hub, yeah. Okay, this is the hub. So for the hub, I have all the loopback IP now coming up on this router showing BGP. So let me just confirm reachability to this hub because it can be showing up here and then not reachable. Some of those MPLS issues. 200 or 200 or 2. Okay, 2 is reachable. How about dot 3? Dot 3 is not, just as explained earlier on. Let me go back to P3 and see what was done there. Yeah. All right. Welcome. Welcome back. So earlier on, I had a brief interruption session. However, um, I was not able to reach from the hub earlier on. I was not able to reach 10.200.3, and though it was showing in the route here. So the only thing I just came to do earlier on at the P2 routing BGP. If you check earlier on, I said this is the BGP process for VPN v4 route, which we connected OSPF and BGP MPLS. So while for the OSPF process, this OSPF is actually, well, let me just allow you to know. While for the OSPF routing, the same router, the P2, because OSPF is I'm doing with the customer routing OSPF, and at the instance, I said connected and BGP because it's still the same connected interface, but this time around, I'm reaching BGP MPLS into P2, into the OSPF process. So the only thing I came to do was I just removed this routing tag. Excuse me. Import route target. I removed it and reapplied it. Then I disabled and enabled this route target. That was the only thing I did, and then I was able to reach the IP configurations I've earlier discussed remain the same. So this is the hub. This is the hub. I'm getting it via from the PE router. I'm getting it via uh, from from the BGP MPLS. As you can see, this is the neighbors loopback, and these two has to be distributed in between each other using OSPF and BGP process. And now, if I want to reach the hub via PE router, these are the command I need to do. These are the command I need to do. I need to say ping the interface of the hub as the troubleshooting steps. Ping this interface connecting to the customer. I can actually ping the customer to which is by 2. Let me come back to the PE router. And then the source address. The source address being the address facing the customer. This IP. And then I'll now specify the routing table, which is the PROF routing table. And I click the ping test. So that was what I did to confirm reachability. That is from the provider's edge router. So for me to confirm the interface of that customer, I'll just put 2 here. So I can also reach the customer interface router. And if I should go to the customer router, let me click from the C branch. Just normal ping test to the hub. I can reach the hub. Now, if the customer demand for service, this is just information for the customer. and the customer want to confirm that it is actually the MPLS that was delivered to him or her as requested by the customer. The customer can simply just confirm. One of the way you can confirm is to confirm using trace route. And if you run trace route, you should see MPLS label in one of the parts. That is one of the ways to confirm. So let us do that. So you can see MPLS label shown here. That is to show that the ISP fulfilled its promise and what is giving you is MPLS. So that is that. And there's something I did. Now, this loopback IP, I'm only able to ping 10, 200 dot 1, but I can't ping dot 2, which is customer, this branch here can't ping this branch, but you can ping the hub because that is the natural design. Because the hub you are accessing is where the server is being hosted, and whatever service is being hosted. But if this customer want to reach this branch, now there are several ways to go about it, not just two ways. The branch that is managing this services that is in a different administrative domain, which can be a bank or a company or whatsoever, they can actually run some tunnel in between itself. They can use static routes to establish connectivity, and they can also demand further from the ISP. The ISP being the load domain, that they want to be able to reach all their branches. If that demand come back to ISP, what the ISP need to do is to use route import and route export targets. What you just need to do is, the import of this guy is sitting on this router. It was imported into the router. The import of this guy is sitting on this router. It was imported into this router. And I'll only import this one back here. I'll only import this guy back here. So if I want full reachability, now you ISP are the one doing the route completely for this customer. And in such a case, the customer has to pay. You have to now import this guy target into this guy. Import this guy target into this guy. And full reachability will confirm. Let's just go do that, and that will come to the end of this class. So I'll go to P2. Remember, from this router here, I can ping from the C branch. I can see loopback is 10.200.200.3. Let's confirm the C branch. While the B branch router, let me see. I'm not opening the B branch. Let me open hub. Let me open the B branch. The B branch loopback IP, let's just confirm. The B branch IP is 10.200. C is so now if I want to ping 10.200.200.3, I can't still reach it. I can only reach the .1, which is the hub. So now for ISP, me now to now complete this route for them, because it's just the natural design that's supposed to occur because they are accessing their server at the hub. So what you need to do as an ISP is just to import their tag, their route target, yes. So I'll go to P1, come to routing, I'll come to BGP. This is where we work. I'll come to P1, that's P1. I'm going for P1. Come to routing, come to BGP. So I'm going to import this export here. I'm going to import it into P1. I'm going to import it into P1. Just full reachability. While this export here, I'm going to export it into P2. So with this full reachability between all the branches should be ensured. So let's go back to B branch and C branch and confirm. Yeah, this is B branch, this is C branch. Earlier on, I could not ping, look at it 10.10.10.2. Let's confirm now. So now I can ping 10.10.10.2. Can I ping 10.10.1? Yes, I can ping 10.10.10.1. Now I'm not even following the hub again to reach the area, studio ISP. So let me go to the B branch to confirm the same. Okay, here's the B branch. I'll ping the loopback of C branch 10.200.200.3, and I can reach. Can I reach the hub as well? I can reach. So let me run a trace route to just see the MPLS part. This is not going to transfer to the hub, it's to the ISP. So it's just to ensure full reachability to trace 10.200.200.3. So it is actually this timeout you are seeing. This timeout you are seeing is because of this. Um, let me show you. If you come to this my diagram, this route reflector, I did not enable MPLS here. I said it's not extremely important. So that is the timeout you are seeing. That's the part it is taking now. If I come to that route reflector router, let us confirm if there's MPLS running in that router. Routing MPLS, you can see no MPLS instance, no MPLS. The only thing I have is VPN v4 for the video router pointing to it. So that is the timeout you're actually seeing on this trace route. So for today, that comes to the end of Mikrotik MPLS based layer 3 VPN, and I hope you enjoy my tutorial. Though it's a little bit lengthy, but that is how it goes because it involves several protocols. And this is like me setting it up from scratch to complete setup. And please, if you find this video session interesting, kindly subscribe, share, and let other people get to know my channel. This is the best you can do for me, and it will be well appreciated. So this is just the advanced topic I've done so far. So subsequent video, I will not going to be doing advanced for them now. I'll be going into VLANs. I'll talk about host router on the stick using CISCO. I'll talk about VLANs in Mikrotik. I'll talk about other interesting topics that will come in an upcoming video session. I also talk about OSPF, I'll talk about BG, I'll talk about the general CISCO, and so much more that will come. So please do stay tuned to my channel, and do ensure you practice just as I've said. I will leave a link of brief intro to this document. Do stay blessed.